Just the chicken plow. You tell me what else is on the menu, please, sir, for today.
Really? Another one of these? This time I'm actually going to explain what I'm doing. This heater is called a milk house heater because back in the day, I guess it was used to heat like a barn or something like that. And it's just the name is hung around. 1,000 different designs, but they're all basically the same. They're a 1500 watt, 120 volt space heater in a metal can, and they're the cheapest space heater money can buy. They also suck, because all cheap space heaters suck. The thermostats are awful. And I've already modified one of these with a better thermostat, but I didn't really explain what I was doing. I'm going to do that to this one too, but I'm going to go too far with it, because this is going to cool the room too. This is a heater opened up for the first time, exactly as it comes from the factory. You can't actually open it up all the way, because the wires are all zip tied, all nice and pretty, aren't they fancy? I cut the cord so we could open it up all the way. Here's what's going on in here. There's the thermostat and the tip over protection. It's all one piece, and it is the cheapest, crappiest thermostat in the world. This is the selector switch, this little neon bulb, and this thing over here is the high limit safety thermostat in case, you know, the fan stops or whatever. Metal springs and a cheap little fan. That's it. That's all there is in any milk house heater. They don't all have this bad of a thermostat. This is the thermostat out of a Walmart milk house heater, and it's honestly better. This one came from Rural King, which is the only store in the United States that sells heaters all winter. Here's why this is such an awful thermostat. As the temperature rises, the contacts very slowly open, like this. See? They're open now. And then as it falls, they slowly close again. So they arc, and they pit, and they destroy themselves. And these are the only thermostats like this. You go to pretty much any other heater, even the cheapest, crappiest ones, cheaper than this, and they have a thermostat that's better than this. The last one of these I did, I kept this thermostat, but I modified it because I wanted to keep the tip over protection. The other thing that can open the contacts is the weight, you see? This is the tip over switch used in the Walmart version. Another thing that they did better, I fucking hate to admit that. Well, anyway, I'm going to take this and install it into that. This is going in the bin. This digital controller will take its place. This digital controller is rated 10 amps. See? Heating, 10 amps, 110 volts AC. The heater uses 12.5 amps. So if I just run the heater through this temperature controller, it's going to burn up. So I've got this salvaged Cridom relay. It's good for 40 amps. And we'll be using that to switch the heater. This fan is pathetic. These sound like a helicopter. And it's just a bit of rubber and stamped piece of metal. So in place of this crummy little fan blade, I'll be installing this fan blade. Something like that. Here's another $16 cheap Polonis space heater that I already took apart so that it'd be easier. And I'm going to take the motor out of it. This motor is twice as powerful as the one that's in the milk house heater. These are the same frame type, but they're different kinds of motor. They have little mounting holes on the back, so I could just replace the shaded pole with the capacitor run motor. That wouldn't be as cool, so I'm going to do it this way instead. I'm swapping the bearings so that I can put back the shitty little shaded pole motor in the Polonis heater. And that's pretty straightforward because these are the same motor. They just have different shaped frame pieces. See the one on the left up top has screws in it. The one on the right doesn't. It's because the screws are in the bottom part. But that's it. That's all there is to it. So I'm gonna put them back together now. And I can put this motor in the heater. And I can put this motor back in this heater. See? Now it'll mount in. These little wires will just stick where the old ones were. Simple. Cool. So now I got to get this motor in here, which, you know, I've been talking about how easy it was and how straightforward everything is, but there is actually a problem. Those screw holes sit right on top of a bit of plastic. So these screws are too long. So I just gotta cut them off. That's pretty straightforward, but I gotta modify the controller now. This is the temperature controller we're using. It's an Inkbird controller off Amazon. It costs like 15 bucks. And now its relays have been bypassed. It puts 12 volts DC out the little connectors at the back. The resistor leads soldered across the terminals. And I took the little beeper out because fuck the beepers. This controller can heat and cool. This little pitiful outlet out of the world's cheapest, crappiest power inverter. Says it's rated 15 amps. That's good enough for me. That's not rated 15 amps. Even a small window air conditioner is going to pull 20 amps or better trying to start a stalled compressor. So I'm going to use one of these 40 amp relays along with everything else in 2 minutes and 10 seconds in an old school style music montage to a song called Searching for Signal of an old war dialer folder buried in the archive. Here's how it turned out. We got two switches, one for cooling, one for heating. That is the heat power level. It only affects the 1300 watt heating mode. 1500 mode just heats like it used to do. Got a little Inkbird controller with its nice purple lens. So it runs fan when you set it to fan, and that's all it is a fan. Tip over protection doesn't affect it. Now if I turn it to heat, see the little heat indicator came on. It says it should be heating, and if I turn on this switch, that light blinks. And if I turn this dial, I can adjust how much time the light spends on versus off. You may also be able to see the lights flickering as the load comes on and off. So it controls its power level by cycling the power on and off so slowly that you can actually see the light blink. It doesn't have to blink that slow, but I like it doing it. So there you go. And if you set it to 1500 watts, it runs 1500 watts. If I warm up the temperature sensor, it'll go into cooling mode. That's what that switch does. It turns this outlet on the side here on and off. It's pretty straightforward. You plug an air conditioner into that, this tells it whether or not it can run. That's all there is to it. Those 4 wire nuts are all that's necessary to separate the back from the front. Here's the 2 motor run capacitors for the fan motor to give it the torque necessary to run the fan a little better. That's the fully custom homemade power control board thing. Look how closely it fits. I didn't plan that, it just happened like that. That little switch is only switching the low voltage that goes into the little heater control board. The other switch is switching line voltage. That's how it gets the neon on it. Everything's pretty well divided. You got the little outlet on the side, the cooling enable switch and the cooling relay all there on that side. And then on this side you have all the heating stuff. The cardom relay, a little timer board, and the enable switch. Along with the tip over protection that's only in series with the heater, because that's the only thing it needs to be in series with. That's the top connection between the 2 heating elements. That's the hot wire. It goes 2 ways. One way is to the cooling relay. The other is to the high limit switch. This is the schematic for the heater. That's the selector switch there. This is supposed to represent all 3 of these being closed if it's all the way to the right. So there's the high limit there, selector switch, fan motor. These are the 2 sections of the heater. That's the relay on the little control board. There's the tip over switch and the solid state relay. That's what runs the heat. This is the temperature controller. It gets its power from the 1300 watt setting, low heat. See, power comes in, powers it. It puts out its power to the heat board through the little heat switch and the little power board there. That puts its power out to the solid state relay. When you turn the switch to high, all that happens, 120 volts goes to this pin on the power board, which closes the little relay here and tells it to stop turning the solid state relay on and off. It starts ignoring the little 555 timer. As for the cooling side, it just puts out 12 volts DC to the cooling relay. That's the cooling relay. That's the little 2-pole switch connected to the outlet, and there's the outlet. That's all there is to putting the cooling part in. That's the indicator light. And you see that it's across the entire heater. And when it goes in high, all that happens is this section gets bypassed. That'll be 1500 watts by itself, but the 2 in series is 1300. Here's the schematic for the high power mode. Resistor, capacitive dropper, full bridge rectifier. Got a little 24 volt Zener diode, a capacitor, and the relay. You know, that relay. Then there's an LED on the board and an opto isolator. The opto coupler is there to bypass the timer and run it at full power no matter what you have it set to, without connecting the mains voltage over here through our cheap little capacitive dropper to the little 555 circuit. This is the most basic 555 PWM circuit in the world, and I found it on Google by typing in 555 PWM. I changed that capacitor to a 100 microfarad to make it run around 1 hertz. because it would have ran faster if I didn't. That needs to be a 1K, that needs to be a 10K potentiometer. I don't think those matter. This right here, and this over here are just indicator lights on the board, and they don't have to be there at all. These two transistors can be any NPN transistor. I happen to use A20s because I like them. You could use 22s or whatever. That could be any ceramic disc capacitor. That's the optocoupler right there. That optocoupler. Same part, see? Now it's a different color because it's from this page. Aren't we clever? These two transistors are in parallel with each other. That one's turned on by the 555. That one's turned on by the high power setting. There's your 12 volts that comes out of the Inkbird controller, and that's the 12 volts that goes into the Cridom relay. That's the entire circuit. There's one other thing I need to sort out. Listen to this. Fan motor is a piece of shit. It needs a little bit of oil. You have to use the right kind of oil for one of these motors. If you use the wrong kind of oil, it ruins everything. Okay. So I prefer to use canola oil because it has 0 grams of trans fat and it has no cholesterol. So that should help. So we just use this chopstick and put a little drop of oil in the lower bearing. Drop a little oil on both sides of this upper bearing. And there you go. Manufacturer's recommended procedure. Motor's oiled up. Just take it back together. Good to go. Much better. And now I'm able to cool my room with a space heater.